Hello, good afternoon. Today, Partip and I will be presenting our continuous integration and continuous delivery CI/CD project, focusing on its application to an e-commerce platform. Overview of the project. So our purpose was to build a scalable and modular e-commerce platform and to streamline product, customer, and payment management through microservices. So the project features include a product service, a customer service, and a payment service. The product service manages product catalog, including creation, updates, and retrieval. Customer service handles customer details, updates, and customer-specific operations, and the payment service processes and manages customer payments. So the technology stack includes backend, database, messaging, validation, and API communication. The backend uses Java and Spring Boot. The database we use is MongoDB, and for messaging, we used RabbitMQ for asynchronous communication. For validation, we used Jakarta Validation API for input validation, and API communication includes Fein Client for inter-service connectivity. And the key characteristics include asynchronous communication for efficient data exchange, and modular design enabling independent scalability and maintenance of services. E-commerce microservices and communication. So our project has three microservices: the product service, customer service, and payment service. So our e-commerce platform leverages microservices to separate responsibilities. So the product service manages product inventory and details. It also publishes product updates to RabbitMQ for consumption by other services. The customer service handles customer details such as name, email, and address, and it communicates with the product and payment services using Fein Client. The payment service processes payment details and records transactions. It subscribes to RabbitMQ for updates related to customers and products. The communication is asynchronous, ensuring reliability. It also includes error handling to improve user and developer experience. The communication mechanism uses RabbitMQ to ensure reliable, event-driven data flow between services. Events like product updates or customer creation are published and consumed. Fein Client enables direct interaction between microservices when needed. The project uses centralized error handling, and it validates input and provides clear error messages for users and developers. The advantages of this design are scalability, flexibility, and resilience. Scalability. Each service can scale independently. Flexibility. It is easy to add or modify a service. And resilience. Asynchronous communication ensures minimal downtime and reduced coupling. The project also uses a MongoDB database, which is a NoSQL database for efficient storage and querying of all service data. It has a flexible schema for handling diverse attributes of customer, product, and payment service. It is connected through Spring Data to MongoDB. The CI/CD pipeline. It's implemented with GitHub Actions to automate building, testing, and deployment. It builds the Maven project, runs unit tests, and pushes to Docker images to Docker Hub. And Docker Compose. It is used for defining and running multi-container applications in development and production environments. It networks and connects all services.
Thank you, Michaela. I'll take over from here. Let's walk through the CI/CD pipeline for our project. Starting with code push and testing, the pipeline is triggered whenever there is a push or pull request to the master branch in GitHub. Using GitHub Actions, it automates several tasks. It checks out the repository, sets up JDK21, and installs dependencies with Maven, runs unit tests to ensure code quality. Once tests pass, we move to building Docker images. Each service is containerized using its respective Docker file. Finally, we proceed to pushing Docker images. The pipeline securely logs into Docker Hub, tags the images, and pushes them, making them available for deployment in containerized environments. Let's discuss the deployment process. After pushing the Docker images, Docker Compose pulls them to spin up the services. We have included RabbitMQ to manage communication between the services. Each service is configured to run on specific ports, ensuring seamless connectivity. Let's highlight the advantage of CI/CD. Automation minimizes manual intervention, enhancing reliability and consistency. Rapid feedback enables developers to quickly identify and fix issues. Continuous deployment accelerates the time to market by deploying changes seamlessly. Testing strategy. Unit testing is the cornerstone of ensuring application reliability. We focus on testing the functionality of individual components in isolation. Using tools like Mockbin and Mockito, we mock dependencies. This helps isolate business logic and ensures the tests run independently of external systems. Now, on the screen, we can see there is two examples of unit testing. One is for getting all the products, and another one is for adding product. And on the right hand side of the screen, we can see all of our tests has passed. Integration testing. Integration testing validates the interactions between different components. For example, we test operations like adding, retrieving, updating, and deleting data across services. Both positive and negative scenarios are covered to ensure comprehensive validation. This ensures that not only do the components work individually, but they work seamlessly together. We can see three examples of integration testing on the screen. Key testing aspects. Here are the key testing aspects we focused on. Test cases for CRUD operations. These ensure that adding, retrieving, updating, and deleting entities like products, customers, and payments functions as expected. Mocking with Mockito. Dependencies like databases are simulated, allowing us to isolate and test the business logic effectively. Database validation. Integration tests confirm that database operations, such as saving and retrieving entities, are accurate. Assertion coverage. We use functions like assert that and assert equals to verify not only status codes but also content, such as JSON responses. Code quality assurance. By covering edge cases and testing for missing or incorrect data, we ensure that the application meets its functional requirements. Challenges and solutions. During this project, we faced several challenges which we overcame with tailored solutions. RabbitMQ configuration issue was one of them. Initially, RabbitMQ worked locally, since we practiced RabbitMQ in the lab, but failed in the containers due to incorrect port mapping. We resolved this by configuring docker compose.yaml file, exposing the required ports, and connecting services using a custom Docker network. Port mapping confusion. Understanding Docker's port mapping was challenging for me. We overcame this through hands-on practice and documentation, which helped the entire team, me and Michaela, to gain clarity. We also faced challenges with collaboration and CI/CD. GitHub collaboration. Merging conflicts were common in a collaborative environment. We mitigated this with frequent team sync-ups and regular pull and push operations. We planned our project roadmap in Jira and finished our project efficiently on time. CI/CD workflow build failures. Tests often caused builds to fail due to dependencies not being properly mocked. We created a separate branch named feature testing for testing related code to keep the master branch production ready. Failures were resolved incrementally, ensuring stable builds. Future improvements. Looking ahead, we have identified key areas for improvement. Enhanced front-end UI. We could plan to develop a modern, user-friendly interface using React or Angular, integrated seamlessly with the backend for a better user experience. Scalability enhancements. Advanced load balancing. Horizontal scaling and Kubernetes-based container orchestration will prepare the system for high-traffic scenarios. Improved CI/CD pipeline. By automating performance and security testing, we aim to enhance testing and deployment workflows for faster release cycles. Advanced features. We envision artificial intelligence or machine learning powered product recommendations and a loyalty rewards program to enhance customer engagement. Thank you for listening. Now it's time to show the actual project. Uh, so this is my product service, and this is my Docker Compose file where I declared all my services. Also, I have integrated RabbitMQ for asynchronous communication between the services, and this RabbitMQ is exposing to port 5672, and my product service is exposing its port to 1990 and customer service to 1993, and payment service is on port 1992. I have also deployed my project on Kubernetes, my services on Kubernetes, so I can run my project through Kubernetes as well. I'll show that later in the video. For now, I can start the service, the Docker Compose YAML file. So if I click on the service, I'll see, oops, yeah, all my services has just started, and in the Docker Compose, in the containers, I can see this customer service is just started and it's just take some time. So finally, my customer service is running on port 8082 and exposing to port 1993, and my payment service is running on port 8083 and exposing its port to 1992, and product service is running on 1991 and exposing to 1991. So if we want to check whether our CRUD operations are working perfectly or not, we can check by running the endpoints. So first check the payments for the payment services. So I have some payments information already inside the database. I can fetch them by get method. So I have already two there. And if I want to insert any new payment details, just post and give new payment ID. Let's say payment method is card again, no cash this time. And since it's cash, it should be null. And let's say the amount is 2, and let's insert it. So details is in, the details are in. And if you want to fetch it again, just there you go. So there you go, 3. And if we want to change, if you want to edit it, it's just payment, payment, and we need to give the ID. So I want to change, I want to edit ID 3, so it will be cash. Cash will be changed to credit, and the method is debit. The amount is same, just the method is changed. And so there you go. So it's working. If you want to check another method, let's say I want to check customers. So for customers, the customer is running on 90. Oh, I think I have it here somewhere. Customer, continue. Yep. So if we want to check first whether how many customers are there inside, there should be a few of them. So I have 3 customers there. If I want to create any customer, I just can do it like this: ID 3 and payment ID 3. Uh, let's call the one, and everything is same. Just insert it. Yep, it's inserted. Let's take a quick overview of our database. We are using MongoDB, and I named the database as e-commerce database. Let's browse the collections. So I have 3 services, and they're using their unique tables for data insertions. So customers, here are the data that we have just inserted, and payments. I have 2 data available for payments, and products. There are only 1 product so far. So far, my code was running via Docker Compose. Now, if we stop the services, um, now let's check the CI/CD pipeline stuff. Let's make a small changes to make the code push to see if whether my code, my GitHub Actions CI/CD pipelines are working or not. So let's say customer. I'll make the commit and test and push. So in my product repository, if I go to the actions, I'll see that I just made a change which I committed by written tests. It's being the CI/CD pipeline tests are being executed. So if I go to the build, I'll see yes. So the test is successful. I got the green tick, and if I show my previous tests, I'll see when I started, I got lots of red sign there, which is not good. But eventually, I fixed everything. So to test the asynchronous communication, we need to run the application locally rather than from the Docker Compose. And also we need to change the branch from feature test or feature asynchronous to master. Uh, so our application is up and running. Now I can check if it's sending the messages to the Revit UI. Since my product service is running, I can check whether I can insert informations or not. So I just insert another information. Let's give it ID1. 126, yeah, let's give it simple, and quantity is 200. Okay, it's inserted. Now I can check the get method whether it's inserted or not. Yes, there's two products. Let's check the Revit UI. My code for Revit UI configuration is here in the product service. So in the product service, it's just the sender. It doesn't consume any messages. So here's the configuration. It is the product test queue. So this is my Revit MQUI dashboard, and I have a couple of messages which are waiting to get published, and they are my previous testing queues. The one that I'm looking for is the product test here, and there's 2 messages which are waiting to get published. And I can see the bar is pretty high, and it's ready to get published. I can see the messages. So the messages that I just sent is this. My customer class is the consumer for the product messages. So I have the code configuration here for receiving the messages from the product test queue, and I have the configuration here, and I can see that it has successfully received the messages here. Finally, in my RabbitMQ UI, we can see that there is only 9 messages in the ready state. That means the messages that we just published from the product service class, they got consumed by the customer class. And if we check the queues, the product test queue, we'll see the queue is empty. So there is no messages which is waiting to deliver. That means the service is up and running and it has received the messages successfully. Thank you for watching the video.